Hello and welcome. In this video we want to learn about the quotient rule for derivatives. If we have function f over function g, if we have a quotient like this, derivative of f over g, if we want to find derivative of f over g, we can use this rule. Derivative of f over g equals to f prime. So, for finding derivative of f over g, find derivative of numerator, derivative of f, multiplied by denominator, minus, then write the numerator is f, so minus f, times it by derivative of denominator, so times by g prime, all over g to the 2, the denominator to the 2. To learn this formula, let me show you some examples that how we can use this formula. Consider this function y equals 3x plus 2 over 2x plus 5. We want to find derivative of this function. Here we have a quotient. The numerator or function f in this formula is 3x plus 2. Denominator or function g is 2x plus 5. Based on this formula, for finding the derivative of 3x plus 2 over 2x plus 5, first we have to find the derivative of numerator, f prime. F prime is the derivative of numerator. Derivative of 3x plus 2 is 3. Derivative of 3x is 3 and derivative of constant 2 is 0. So derivative of numerator is 3. We have to multiply it by the denominator, 2x plus 5, minus, write the numerator, which is 3x plus 2, and multiply it by derivative of denominator. Derivative of denominator is 2 because derivative of 2x is 2 and derivative of 5 is 0. All over the denominator to the power of 2. This is the derivative of that function. Here, if you want, you can simplify the numerator of the fraction. Let's keep the denominator. Attention, here we have 6x plus 15. If we multiply 3 in the bracket, 3 times 2x is 6x, 3 times 5 is 15. And if we multiply these 2 inside this bracket by considering this negative that here is for all of this, then we have minus 2 times 3x minus 6x, and then we have minus 2 times 2 minus 4. Again, don't forget this minus is for all of this, so when you multiply the 2 inside this bracket, always you have to apply and consider this negative. So basically numerator is this 6x plus 15 minus 6x minus 4. 6x and 6x cancels. 15 minus 4 is 11. So when we simplify the numerator, it equals 11. So we have 11 over 2x plus 5 to the 2. Let me rewrite this here. The answer is 11 over 2x plus 5 to the 2. Let me show you another example. Consider this function. Y equals e to the x plus x over e to the x plus 1. We have a fraction, and for finding the derivative of this, we need to use quotient rule. Based on the quotient rule, derivative of this function equals to take derivative of numerator. Remember the quotient rule, f prime. F is numerator, f prime is derivative of numerator. So first we have to find derivative of numerator. What is derivative of e to the x? We know that the e to the x is the only function that its derivative is itself. Derivative of e to the x is e to the x. Plus, what is derivative of x? 1. So derivative of numerator is e to the x plus 1. Multiplied by the denominator minus, write the numerator and multiplied by derivative of denominator. Derivative of e to the x is e to the x and derivative of 1 is 0. So derivative of denominator is only e to the x. All of this over e to the x plus 1 to the 2. A mistake that some students make here is that they think that they can cancel, for example, this e to the x plus 1 with this e to the x plus 1. Attention, you can cancel something from the numerator with denominator if that factor is for all of the numerator and denominator. Attention, this e to the x plus 1 in numerator is multiplied by this only, and we don't have such factor in the other bracket. So this is completely wrong to simplify this by cancelling e to the x plus 1 from numerator and denominator. Here, similar to the previous example, it's better to keep the denominator as this. Do not try to expand it. Do not try to do anything with denominator. Only thing that you can maybe simplify this expression a bit is to multiply this bracket by this bracket and multiply this e to the x in this bracket, and then probably you can find some terms that you can cancel from numerator, but it would not be so much significant, and so basically we cannot simplify this answer so much. So I prefer to leave it like that. Let me show you another example of quotient rule. Here we are given this function g of x equals 2 plus sine x over cosine x, and we are asked to find g prime of 0. So we have to find derivative of the given function, and then we have to substitute 0 for x. Again, we use quotient rule for finding derivative of function g. G prime, derivative of function g, equals to, take derivative of numerator. Derivative of 2 is 0. Derivative of sine x, probably you know that it is cosine x. Derivative of sine is cosine. So derivative of numerator is cosine x multiplied by the denominator. So multiplied by cosine x minus, write the numerator itself and multiplied by derivative of denominator. What is derivative of cosine x? If you remember, derivative of cosine x is negative sine x. All over the denominator to the 2, cosine x to the 2. Now we have to plug in 0 to find g prime of 0. So g prime of 0 equals to, if we plug in 0 here for x, cosine of 0 is 1, cosine of 0 is 1 minus sine of 0 is 0. 2 plus 0 is 2, so minus 2 times. This is also 0. Sine of 0 is 0. Negative of 0 is 0. So this is 0. All over cosine of 0. Cosine of 0 is 1. 1 to the 2. Numerator is 1. 1 times 1 is 1. Denominator is 1. So g prime of 0 is 1. So the answer is 1. G prime of 0 equals 1. Now let me show you another question. We are given some information about function f. If we know that f of 2 equals 3 and f prime of 2 equals negative 6, we are asked to find d over dx of f of x over x. We don't know what is function f, just we have some information about function f. We know that f of 2 is 3, f prime of 2 is negative 6, and we are asked to find d over dx of f of x over x when x equals 2. So we want to find, attention, this notation is a notation that sometimes we use for showing the derivative of something. So when we have this notation outside of a bracket, this means that take derivative of that bracket and then substitute this number for x. So this is just a notation for derivative. So in this question, we are asked to find derivative of f of x over x. After finding derivative, substitute 2 for x. For finding derivative of f of x over x, we use quotient rule. D over dx, again, this is just a notation. The notation should not confuse you. I know that sometimes the notations are really confusing, but you have to gradually get familiar with the notations of derivative. D over dx of f of x over x simply means take derivative of the expression inside the bracket. For finding derivative of f of x over x, we use quotient rule. What was quotient rule? Take derivative of numerator. Derivative of f of x is f prime of x. So, derivative of numerator is f prime of x. Multiply derivative of numerator by the denominator by x minus. Write the numerator function, whatever it is, f of x, times by derivative of the denominator. Derivative of x is 1. All over the denominator to the power of 2. Now, we have to plug in 2 for x. When we draw a vertical line like this, and we put a number here, this means that substitute that number for that variable. This is again a notation. So here, now we have to substitute 2 for x here. If we do so, we have f prime of 2 times by 2 minus f of 2 over 2 to the 2. What was f prime of 2? F prime of 2 is given negative 6. So we have negative 6 times 2 minus f of 2. F of 2 is given 3 minus 3 all over 2 to the 2 or 4. Negative 6 times 2 is negative 12 minus 3 is negative 15 over 4. So the answer is negative 15 over 4. Now let me show you another question of using quotient rule for finding derivatives. Find equation of tangent line to the curve y equals 1 over 1 plus x to the 2 at x equal 1. We want to find the equation of tangent line to this given curve when x equals 1. Whenever we want to find the equation of a tangent line, we have to find the slope of the tangent line. This is the most important thing that we need in general for finding equation of any line. And also for tangent line, we need the slope of tangent line. But what is the slope of tangent line? A slope of the tangent line is the derivative of the function. We know that. One of the interpretations that we have for derivative of a function, for dy over dx, derivative of the function, is the slope of the tangent line, a slope of the curve. So we have to find, first of all, the derivative of this given function. And why we are doing so? Because we want to find the slope of the tangent line. Derivative of this given function equals to, we use quotient rule. Derivative of numerator is 0 times by denominator, this is 0. 0 times by anything is 0, minus, write the numerator, times by derivative of denominator. Derivative of 1 is 0, derivative of x to the 2 is 2x, all over 1 plus x to the 2 to the 2. If we simplify this, this is 0. So we have negative 2x over 1 plus x2 to the 2. This answer here is the derivative of this function. And derivative of a function shows the slope of the tangent line. But we want the tangent line when x is 1. So we have to plug in 1 for x to find the slope of the tangent line at this particular point, 1. If we plug in 1 for x in this expression, we can find slope of the tangent line when x is 1. The slope of the tangent line, we use usually m to show the slope of a line. So a slope would be negative 2 times by 1 over 1 plus 1 to the 2 all to the 2. This equals negative 2. This is 1 plus 1, 2. 2 to the 2 is 4. So a slope of the tangent line is negative 1/2. Now that we have the slope of the tangent line, we can write the equation of the tangent line. But we need one more thing. We have the x coordinate of the point of the tangency. But if you remember the equation of a line in general, usually we use this for writing equation of tangent line. A slope is negative 1/2. X sub 0 is given 1. But we need the y value corresponding to this x. What is y value when x is 1? Plug in 1 in this function. Simply we can find the y value when x is 1. If we substitute 1 in this function, when x is 1, the y value corresponding to 1 is 1 over 1 plus 1 to the 2. It equals 1/2. Now we have everything that we need for writing equation of the tangent line. The equation of the tangent line would be y minus 1/2, a slope negative 1/2 times x minus 1. This is the equation of the tangent line at that given point. If you want, of course, you can simplify this and you can rewrite your answer as this: y minus 1/2. If you multiply negative 1/2 in the bracket, we have negative 1/2 x plus 1/2. If we move this negative 1/2 from here to here, or if we add 1/2 to both sides, finally we get y equals negative 1/2 x plus 1/2 is 2 over 2 or 1. So it's up to you to write the equation of tangent line in this form or in this form. Both of them are acceptable. It's completely up to you which form do you prefer. Before I finish this example, let me show you the graph of this function, and I want to draw the tangent line to that curve at that point. The graph of the function y equals 1 over 1 plus x to the 2 is something like this. This is the graph of that function. Let's suppose 1 to be here. If we draw the tangent line at 1, if we draw the tangent line, this is the tangent line that we have here. And equation of this line is this. Attention, you don't need to know the graph of this function. I just draw it here to understand what is the graph, what is the tangent line, how they relate to each other. And so it's not necessary for you to be able to graph of this function right now. And this curve, this function, is famous to which of Maria Agnesi? She was a mathematician, I think in the 7th century. And this curve is famous to which of Maria Agnesi? Here you can see its graph and its tangent line at that given point. I hope you liked this video and see you in the next videos.